Okay, so yeah, we're going to be doing, it's actually two demonstrations, but one of them is going to use this Google Forms link right here. And so I'll give you a list of words here in a second, and I'll show each word for like a second, so not very long. And I will be later testing your memory of the words in the list. So I'll be giving you a list of words, and I will later be testing your memory of the words in the list. And so let's start now. Okay, so here is the word list now. So I'm going to give you, once again, there's like several words, 15 words or 20 words or so. I'll show you each word for about a second. And your job, and I later will be testing your memory of these words, but do not write them down. So only you can use your mind to help you remember them or whatever. Don't write these things down. That would be cheating. Okay, so we'll start now. Okay, so that was the word list. Now what I want you to do is, starting from the number 547, I want you to count backwards by 3 for 30 seconds. So please start now, starting at 547. Count backwards by 3, starting now, and I'll count out 30 seconds. Okay, so now you can open up the Google Forms link that I had for you. Actually, I'll go to that too. And you're going to be answering these questions, so I'll go to the Google Forms link so you can we can do it together. I think my PowerPoint's froze. There we go. What's the shortcut to force quit? Anyone know off the top of their head? Shortcut to force quit on Mac.
Oh, I don't know on Mac.
It's, what is it? I'll have to Google it. Force quit. Option Command Escape. Option Command Escape. Stop this one. Oh, my mouse isn't working now. So now let's reopen those things. Okay, so hopefully you can use this time. If you haven't, you could input your responses into the Google form right now while I'm opening it. So here's question number 1. in that list, how confident are you that the word marker appeared on that list? If you are very confident it was not on the list, give it a 1. If you are very confident that it was on the list, give it a 7, and you are encouraged to use the full range of the scale. Are people having trouble? If you're having trouble, are people able to enter their responses?
I could be wrong, but I think the link you sent for me is like opening as if I'm going to edit this.
Yeah, it's in edit mode right now.
Okay, well, go to where can you? Does it say preview? Is there that eye right there? Can you click on the preview?
Yeah, if you do that, it works.
Yeah, just go ahead and do that.
Cool, thank you.
Yeah, no, definitely. Hopefully this works. It worked when I tested on myself earlier. I'll go ahead and check out. So go ahead and answer these. That's the first question. How confident am I that the word marker was on that list that we just watched? And then the second question, how confident are you that the word mango appeared on that list on a scale of 1 to 7? 7 means very confident it was on the list. 1 means it definitely was not. And then the final one, how confident I am that the word pear was on the list on a scale of 1 to 7. Go ahead and input your responses and press submit. And then we will be able to look at the data here together in a second. Oops. Okay, so I'm going to go look at the data. I see not everyone's done a response yet. Are there still people waiting? I see like 5 people have done a response. I'll wait like 20 or 30 more seconds to see if people are still entering responses. Yeah, there we go. There's some extra people done it. I don't remember the starting number. It was around. So that's almost everybody. So we'll go ahead and look at the data. If you're still entering your responses, that's fine. So I'm going to open up the Google Sheet here. So I will incorporate here are your guys' means. I guess I can. So like these are the ratings. So we have a smaller class since we're doing things. Since this class is only partially synchronous, so a lot of people are watching the videos on YouTube later. Not everyone's here right now. So I'm using data. I'm adding your guys' data to when I've done this in a previous class before. And I'll include, so here are the means for those 3 words previously, and these are basically the old data. And so your guys' data is appearing on the Google Sheet. It's down here. So 1, 2, 3, 4, 5, 6, 7. It looks like 7 people contributed scores today. So we will look at your scores right now. We don't know whose or whose. Yeah. Okay. Some missing data points, but that's okay. And copy and pasting here, paste special values, turn these things into numbers format, number. All right. And so here are the means. So we incorporated you guys today, and here are the means of these 3 conditions right here. So the really crucial, so once again, okay, well, first off, let's go through the list now. So we'll go together. We have to open up that file. Once again, watermelon, apple, lemon, peach, orange, kiwi, strawberry, mango did appear, grape, cherry, nectarine, raspberry, lime, and that was the whole list. Let's go back to the Google Sheet here. So the means of these 3 conditions are right here. And so people in when asked about marker, people said overall that they were very confident that marker was not on the list. Some people, not everyone, I guess one person thought marker was definitely on the list. But most people on average thought that marker was definitely not on the list. And it wasn't on the list. But why was it very easy? Why were people so good at saying that marker was not on the list? Why was that task easy for you?
Because all of the terms were fruits and marker is not a fruit.
That's right. Marker is in a different category of things. It's a different semantic category. And so it's very easy to say, no, marker wasn't on that list because everything was a fruit and you would have remembered if there was something that was not a fruit on the list. Mango did appear on the list, and you guys successfully did say almost very high marks. People were saying, yeah, mango definitely did appear on the list. And you guys are right. That's the one that people said appeared frequently on the list. The really interesting finding, and you guys actually showed it quite finding, the word pear did not occur on the list. And so if you compare pear to marker, this is the really crucial comparison right here, marker to pear, because neither of these words appeared in the list. But pear, you were significantly, and I actually could do the statistical analysis, you had a significantly harder time saying no, pear did not occur on the list. It didn't occur on the list, but your ratings for this were higher, indicating that some of you were more likely to think that pear occurred on the list than that the word marker occurred on the list. And based on the previous students' response, it's kind of the same idea. Pear, that's hard to reject. It's hard to say, no, pear was not on the list because pear is a type of fruit. And so if someone asks you about pear, it's a type of fruit, it's hard for you to remember clearly. Your mind says, yeah, I saw the word fruit or I saw the word pear because the things were fruits that I just saw. And so pear conceivably could have been one of the words. So neither marker or pear were words that you saw on the list, but you're more likely to report remembering pear because it's a fruit. Well, it's easy to reject. It's easy to say, no, I didn't hear marker because it is not a fruit. So that is the first memory demonstration. And we'll talk about that one in a second, but since we have these memory distortion things open, let's have the slides open. Let's just go ahead and do the other one as well. So here's the second demo now, the second little task. So now I'm going to give you a list of words, and I'm going to ask you to remember things about these words once again. So here's a new list of words. Let me get this on the correct view. Okay, starting now. Okay, and so I'm not going to actually count backwards by 3 this time because we're not going to collect data for this one. But usually in an laboratory, the participants would do they 547 count backwards by 3 for 30 seconds. The purpose is to prevent rehearsal, to occupy your short-term memory, and then we're going to test you on your long-term memory. Actually, why don't you go ahead and do this? Write down as many of the words in that list as you saw as possible. All right, write them down or type them into your computer. Please don't cheat. There's no way for you to cheat, actually. So just go try and write down as many of the words as you possibly can or type them, and I'll give you like 30 seconds to do that. All right, 10 more seconds. Trying to retrieve as many of the words from that list as possible. All right, so now I have a specific question, which is the question which is asked by the researchers. By the way, if you read the textbook, then you already know the purpose of this demonstration. The question which researchers ask, or the thing that they're looking for, is the percentage of participants that include the word window into their list of words that they were able to recall. I'm curious, did anyone in their list of words, did they write the word window? Did anyone?
Yeah.
Good. Yeah,
Yeah.
it sounds like a couple people. But window did not appear in that list. Let's actually look again. Shutter, screen, sash, breeze, view, frame, curtain, open, house, sill, ledge, shade, pane, glass, door. Those are the 15 or so words. None of those is the word window. But a very common, when people hear this list of words and they're asked to recall the words in the list, a very common error, a very common memory distortion is falsely believing that you heard or you read the word window when actually you did not see the word window. In case you're curious, according to the textbook, all of these words, shutter, screen, etc., these are words which have strong co-occurrence with the word window. So if a person in real life is talking about a window, these are the words, the other nouns, which are most likely to co-occur in that sentence. When people are talking about windowsill, window ledge, shade, window pane, these are the words that are most likely to be used with the word window. And so they're words that you strongly associate with the word window. And the idea here is that the reason why some people mistakenly believe they read the word window is because these words are all strongly associated with the word window. And when you hear all these words, it kind of activates in your mind the concept window. And because that concept is activated in your mind, you actually think that you just saw the word window, when really the concept of window was activated because of all of these words that you saw, that you read, that are associated with the word window. So now those are the two little memory demonstrations. Now we'll talk a little bit about some important concepts related to these. So these would both be examples of, the book calls these false verbal memories. Though I think it makes a lot more sense if you include the word semantic. So on a test or whatever, I wouldn't count it off wrong if you just wrote false verbal memory. But really, these are memories that are these are semantic memories, or memories that are based on schemas, a word that we'll talk about here in a second. Once again, the book calls these false verbal memories. And these are memories where you're exposed to something, like a list of words in the two examples, and you make mistakes about what words occur in that list because of the semantic relationships there's usually one semantic relationship that exists. In the second list, the semantic relationship was window. In the first list, the semantic relationship was fruits. And you make mistakes about what words did or did not appear based on the category. Most people mistakenly think pear, are more likely to think pear occurred in the list, even though it didn't, because it's a fruit. That's list one. And in list two, people are more likely to think window occurred in the list because it was implied by the schema, it was implied by the meaning of all of the other words in the list. And so the book talks about this idea of source monitoring, which it basically is a skill that people vary on. And it's defined here. Basically, the ability to go back to when you learn something, or go back to the source of a memory and evaluate it retrospectively. Did I actually have the sensory experience of seeing the word pear, of seeing the word window? Or am I believing that I saw that word because it was implied by the semantic or conceptual relationships of the words in each individual list? So source monitoring requires you to kind of retrospectively evaluate, did I actually see it with my own eyes, or was it implied semantically? That's what source monitoring is. And people vary in this ability, presumably. People that are really good at source monitoring will know that they did not see the word pear. They'll realize that they did not actually see the word window. So both of these examples, both the pear example and the window example, these illustrate reconstructive retrieval. This is a term in chapter 6. It's when some type of schema, which is a term I haven't defined yet. You can kind of think of schema is like semantic relationships among things. or it's a set of knowledge. I actually just defined here, a set of knowledge about a given set of things or a given subject. It also says a mental framework. So it's a body of knowledge about fruits, or it's a body of knowledge about windows, which you could also think of that as a mental framework. And we'll also give some other examples of schemas in future examples. But this is an example of reconstructive retrieval, when the fact that you have knowledge in your mind, it's actually distorting your episodic memory. It's your experience. Was the list that you heard, did it contain the word pear? Did it contain the word window? And then you answer yes or no, or you give them the number ratings like you did earlier. That's episodic memory. You're evaluating your own personal experience. Was the list that I read, did it contain these words? And your schema knowledge, the knowledge that you have in your head of pear is a fruit, distorted your performance on this task. The fact that all those words were related to window made people more likely to report window. It was more likely to cause memory distortions. And so, yeah, I think I've defined everything on the slide now. Yes, are there any questions then about how this is, what a false verbal, that is a false verbal semantic memory is, what reconstructive retrieval is, and what schemas are? Any questions or comments about these examples and what is illustrated by them? Okay. Well, let's see how we're doing on time here. We'll do like 10 more minutes. So here's another example of reconstructive retrieval. This was described in the textbook, so I'm not going to talk about it in too much detail. But it's another example of where it's like a memory error, where you make an error in retrieving some type of memory or some type of knowledge because of knowledge that you already have stuck in your head. So this is a pretty famous picture. I definitely remember seeing this when I took cognitive psychology, almost 15 or 20 years ago. I definitely remember this pretty famous study. Some students came into a office, so that's like a professor's office. And they were kind of, the whole purpose of the experiment was just to have them kind of sit in that office for a while. And then they leave the office like several minutes later. And then they're asked to remember as many of the objects that were in the office as possible. So it's a professor's office, but it's lacking some typical professor things. And I don't remember the specific things they mentioned in the textbooks. You can go look that up yourself. But in the textbook, they talk about the idea that when the students were later asked what objects were in the room that you were waiting in earlier, students were likely to make errors of things that typically appear in a professor's office. So maybe things like chalkboard, or maybe things like computer, all things that are schematically associated with the professor's office. When people were asking to remember as many things as they possibly could that they saw in the room earlier, they were more likely to make errors that were stereotypically, or things that you would typically associate with what you would find in a professor's office. So once again, it's a reconstructive error. You're thinking that you saw certain objects because of your schematic knowledge. Your schematic knowledge is actually kind of impairing. It's actually kind of hurting your performance. It's making you have not true memories that are not actually accurate, things that did not actually occur. Reconstructive retrieval errors because of schematic knowledge. Okay, so far we've talked about how schematic knowledge can get in the way of retrieval. The term now that we're going to illustrate with an example is selection. This is how schemas are really important for encoding. How that when you have a schema for encoding, it makes it easier to understand information that you are reading or hearing compared to if you don't have a schema when you are reading that same information. So we'll illustrate this to make it much more concrete. It's the idea of selection once again. Go ahead and read this right here. Read this sentence or this paragraph right here, and I'll be testing. And if you are a participant, you would be told that your memory of this paragraph will be tested in the near future. So go ahead and read this. I'll give you 30 seconds to read this. All right, so that's an example in the book. So you might have seen this in the book already. If you have, what this will be a review. But most people, when they read this the first time, it's difficult. Me, the first time I read it, it's very difficult to understand. And if you were to the first time I read this, if you were to ask me what did I just read, I barely remembered anything. And I imagine a lot of you guys read that and it was very difficult, and you probably don't remember too much of what you just read. And the author that talks about this phenomenon in the textbook called it effort after meaning. You're using your mind right now and you're really struggling. You're trying to come up with the correct schema. You're trying to understand what it is you're reading. You're trying to produce meaning out of it, trying to get a big picture understanding of what this procedure is, which is being described. But this effort, it's difficult because the schema has not been provided to you. You don't understand what you're reading because you don't have the correct schema. I'm curious, is there anyone that has not read the textbook that was able to figure out what this was about?
Is it about laundry?
It is about laundry. I don't know. Yeah, you may have, that answer is in the textbook, but it is about laundry. So if you reread it now, it makes a whole lot more sense. The procedure is actually quite simple. First, you arrange the items, that's referring to clothes, the laundry, into different groups. One pile be sufficient depending on how much there's to do. Like all this stuff makes sense. It makes a whole lot more. It makes a whole lot more sense when you think about it in terms of the schema of doing laundry. And so usually the way this experiment works is one group of participants, they just read it without knowing the schema. They did not hear the word laundry. And then they're asked, they see this, and then they'll be asked memory questions about this. Like, was this part of the procedure that you just read about? Another group of people, they'll read this, but before they read this, they're told this is about doing the laundry. And then they'll read this, and then they'll be asked the same questions that the other group was read at. Is this sentence, was this in the procedure that you just read about? And what they find is the people that are told about the schema, that told that this is about doing laundry, remember more information about this paragraph than the people that are not given the schematic knowledge. So what this suggests is that having a schema in your mind, in this case, laundry, those activities which are associated with doing laundry, this helps you make sense of the thing you are reading. And this is actually a really common thing. I remember when I was in graduate school, the first year you have to read tons of psychology articles, and it was kind of hard. I'd read articles, and while I was reading them, it was just like, I don't understand this at all. And it was just very difficult. I'd spend hours reading like a 10-page article, and it was just very difficult. But eventually, I kind of slowly developed schematic knowledge. I started having a big picture understanding of my particular field, music perception and rhythm perception at the time. And so after a couple of years of reading a bunch, the first couple of years, it was really hard. But then I started having kind of this strong knowledge in my mind. I had the schemas in my mind so that when I would read an article, I kind of could evaluate the meaning of the words I was reading in terms of the knowledge that I already had in my head, which made it much easier to understand, which illustrates this idea of selection, which is most simply illustrated in this example right here. That is selection. You're using the schema to help you encode things. So in this case, the schema is helping you. When we talked about how schemas influence retrieval, we talked about how schemas can cause memory distortions in retrieval. But this example of how schemas influence encoding, the schemas are helping encoding. Let's see if we want to do anything else. Yeah, let's call it a day, actually. We will finish up chapter 6 next time. We'll get a little bit of chapter 7, and that will be done. I'm happy to talk to people about their anything you guys want to talk about, including paper, since we have time here towards the end of class. So stick around if you want to do that. Otherwise, please feel free to email me if you want to make a Zoom appointment. Otherwise, I will see you next Monday.